So the last part we have to cover before you get to your homework is what happens when we have larger denominators and fractional strings. And what those are denominators that aren't as small as the ones that we practice. They're like larger two-digit numbers. And then fractional strings are adding and subtracting several fractions at a time. So what I want to do is show you a different strategy that will also work for the other ones, but for larger denominators, there's certain strategies you can use that lends itself really well. What I'd like you to do is copy these down. This is example 1. Put it in your notebook and give yourself lots of space. Our first example is negative 5/6 plus sign negative 2/9. And the first thing you need to notice is the operation that's going on between them. So between these is a plus. And you know with plus we don't have to do keep change rule. And so what that means is we can just go right ahead and get a common denominator. Now, I want to work on denominators a lot larger than 6 and 9. But with this exact problem, I'm looking to show you the process without getting bogged down by all the big numbers. But I want to show you the process here. Do you see how 6 and 9 have a common factor? Do you know of a number that goes into 6 and 9? Me too, it's 3. So what we're going to do is we're going to write down, okay, this is 3 times 2, and 9 is 3 times 3. This is a different strategy for finding a common denominator when your numbers are bigger. If they have a common factor, that's awesome, because what we're going to do with that common factor, after we write them down, now this is like 3 is the common factor times 2, 3 is the common factor times 3. And as soon as we find the common factor, we're going to cancel it out. We're going to cross it out. And the reason why we're doing that is because they're already in common. We don't need to do anything else with that. When we're trying to get a common denominator, I need the other ones as well. So these are the numbers that you're going to swap. So the 2 needs to go on this side, and the 3 needs to go on this side. And remember that whatever you do to the bottom, you have to do to the top. So when we swap, if you have a left side number, it goes to the right fraction. The right side number goes to the left fraction. And whatever you do the bottom, you do the top. Now check out what happens. If we in fact find a common factor and we cross it out and we swap the other numbers correctly, we should have, in step 2, common denominators. Step 2 is, remember, you need to remultiply and get your new fraction. 3 times negative 5 is negative 15, and 3 times 6 is 18. Plus sign. Negative 2 times 2 is negative 4, and 9 times 2 is 18. If you get to this step and you don't have a common denominator, then that means you messed up somewhere over here. So you need to stop and try again. But if you have a common denominator, our last step is to keep it. And then this is negative 15 plus negative 4. And remember, 2 negatives added together give you a bigger number of negatives. This can be a negative 19. Because they're on the same team. And we're done with that one. Now what we're going to do is we're going to take a look at one with much bigger denominators. And you need to leave yourself lots of space. Lots of space. So I'm going to scoot this up. It's fractions that, when you're trying to write your fractions out and show your work, you don't want to get cramped. You want to be able to see everything you're doing. So this fraction is negative 1 over 35. Minus sign, then negative 9 over 40. What's interesting about this one, and remember, we always start with what operation are we dealing with. And in this problem, we are looking at a minus sign. This is a subtraction. And subtraction tells us that we need to keep change. You always keep change for subtraction. So before we dig into the denominators, what we're going to do is we're going to rewrite this, but we're going to use the keep change method. So I'm going to have -1 over 35. That's my keep. I'm going to change this minus to a plus sign. And I'm going to change this -9/40 to a +9/40. Now that we have an addition sign, now we can do our common denominator. Looking at these numbers, they're a little bit bigger. They're certainly bigger than 6 and 9 and 2 and 7 and 1 and 8. You know, those small ones, these are bigger numbers. So let's try this method of common factor to see if we can get a common denominator. Our first step is to see, do these have something in common? I can tell right away that both of them are divisible by 5 because one ends with a 5 and one ends in a 0. So I just have to think about, this is 5 times what? 7. This is 5 times what? 8. And we know that the 5s are in common. We already have those, so we're going to take those out. We do not need to use the 5s. We already have them. They're already in common. We just want the other ones. So now I have to swap with a 7 and an 8. The 7 is going to go over here with the 40. And the 8 is going to go over here with the 35. Remember, whatever you do to the bottom, you got to do to the top. So 7 here, 7 here. 8 down here, 8 up here. Now we're ready to do the second step. Second step is remultiply and figure out what your new fractions are. So 8 times -1 is -8. If you need a calculator for this, please pull it out and give it a shot. I need to check what 8 times 35 is. So I get 280 for that. Plus sign, because remember we did keep change. And then I need to do 9 times 7, which is 63. And 40 times 7, which is 280. Look at that, we did it right. In our last step, we need to keep our common denominator. And we need to add the numerators together. But remember, I've got -8 and +63, so they're at war. Remember, the bigger team wins, so I'm going to end up with a positive because 63 is much bigger than 8. But the 8 aren't going down without a fight, so we have to take 8 away from 63. So doing a little mental math from last time, 63 minus 10 is 53. So then I got to add 2 more on, so 55. And here's what I see. I see that these 2 numbers here, one ends in a 5 and one ends in a 0. That means that they can be reduced by 5. So I'm going to take my answer. I'm going to rewrite it here. And I'm going to divide the top by 5 and the bottom by 5. And again, you know it's divisible by 5 because 5 goes into anything that ends in a 5 or a 0. 55 divided by 5 is 11. And I need to do 280 divided by 5. So 280 divided by 5 is 56. And there we go. We just finished our big problem. This was a doozy. It had a large denominator where we had to find a common factor. That was our strategy. We swapped them, and then we combined like terms, And boom, boom, there it is. So now what we're going to do is move on to the third example. Give yourself lots of space. Lots of space. Our third example is negative 2/15 minus 7/12. What's interesting about this is there's no parentheses anywhere, and that's exactly how it's written. So we need to make sense of this. Do you know that this little guy right here is a minus sign? And you know that when we have a minus sign, we need to keep change. So we're going to keep our first one. We're going to keep our negative 2/15. We're going to change this to a plus sign. And this 7/12 needs to be changed to a negative because it's positive right now. This is this thing I'm changing. This just stays 7/12, so I have to change that to negative 7/12. So you can choose whether you want to put it in parentheses or not. This problem, they didn't. Your next step is you've got 15 and 12, and they're a little bit bigger. So we're going to look for a common factor. So our common factor for 15 and 12, what goes into both of them? It's 3, right? This is 3 times 5. This is 3 times 4. We're going to cancel out the 3's and swap the 5 and the 4. So the 4 is going to go left. And the 5 is going to go right. And we're going to get ready to do step 2, which is remultiply and find your new fraction. 4 times negative 2 is negative 8. And 4 times 15 is 60. Plus sign. Negative 7 times 5 is negative 35. And 12 times 5 is 60. Perfect. Common denominators. So all we have to do now is keep our common denominator. Look at our numerator. I got a negative plus another negative on the same team. We're going to group them, make them bigger. And this should be 35 and 10 is 45 minus 2, 43. Negatives. Now, let's look over here. Is there any number you know that can divide top and bottom by the same number? No, because 43 is prime. So this one is done. So I hope you get the idea as to how to do the keep change with the fractions, how to use the common factor strategy for larger denominators, and our finale is our fractional string. It's a doozy. Let's take a look at it. Last one for this lesson. Negative 11. You know what? I need another piece of paper. Hang tight. Okay, sorry about that. Need to get new paper because we need a lot of space. So next, we're going to write our last question down. And here it is. This is example 4. Our number string with fractions is negative 11/16 plus 5/32 minus negative 1/4 plus 7/8. Now, people typically would look at this and go, oh, that's too much. But we know a little bit more now. The first thing we need to do is look at operations. So between this fraction and this fraction is a plus sign, so we don't have to keep change. But this is a minus sign. So that right there is an indication that we have to keep change. And that seems to be the only one in this string. That's the only subtraction sign. So that means that when we do the problem, we're going to start by rewriting -11/16. We're going to keep the 5/32. We're going to change that minus sign down here to a plus sign. We're going to change this -1/4 to a +1/4. And we're going to bring down that +7/8. Our next strategy is we need to see, because we have so many different denominators, is there a common factor that all of them have? And in fact, there is. Every single one of these is divisible by 4. 4 goes into each one of those. So we're going to use 4 and see what you're going to have to cross out and what you're going to keep. So 16 is 4 times 4. 32 is 4 times 8. 4 is 4 times 1. And 8 is 4 times 2. So we're going to cross out all the 4s. Now, what we want to do, and this time, is try and get all of them to be the same. So I've got a 4, an 8, a 1, and a 2. So what all of these need to do is make or multiply to 8 when we're all done. This will be multiplied to get 8. This will be multiplied to get 8. This will be multiplied to get 8, and this will be multiplied to get 8. Okay, and that way they'll all be the same. It's different when you have multiples in a string. So to make 4 into 8, you have to multiply by 2. So I'm going to take this fraction and I'm going to multiply by 2, top and bottom. What do I have to do to 8 to get 8? Nothing. I don't have to multiply by anything, so I can leave that one alone. What do I have to do to 1 to make an 8? Oh, I got to multiply by 8. So I'm going to multiply by 8 on the bottom and 8 on the top. And then what do I have to do to 2 to get to 8? I'm going to multiply by 4. So I'm going to multiply the bottom by 4 and the top by 4. And what should happen is we are creating a common denominator. We got rid of our common factors, and we saw what was left, and we had to come up with a way to get all of those numbers to match. And every single one of those is divisible or can go into 8. So that's how we do it. The next step, and I need a whole other line for this, again, lots of space, is we're going to rewrite this. This is step 2. We're going to rewrite this by remultiplying and getting our new fraction. So I have 2 times -11, which is -22. 2 times 16 is 32. Plus sign. I don't have anything here, so I'm just going to bring that one down. Plus sign. 1 times 8 is 8, and 4 times 8 is 32. Plus sign. And 7 times 4 is 28, and 8 times 4 is 32. So look at what we have. So by doing the common factor method, what that did was it lowered the numbers enough for us to get them to manipulate to be the same. Again, this is a 4, and I'm looking at all these leftovers, and I'm like, okay, I'm not swapping everything. That would be crazy. I'm just trying to get these leftover numbers to be the same, okay? So the 8 works for all of these. And that lent us to all 32s. Last step. Keep your common denominator. And we've got to combine our like terms. Now, this is where the number strings comes together again. This is a negative, so this one I'm going to box out in red. That's a negative. all the rest of them are positive. So I'm going to box these out in blue. You can use a highlighter if you want. So what I have now is I have a negative 22 and a positive. We got to add all these up now. These are all on the same team. 28 and 8 is like 28 and 10. That's 38 minus 2 is 36. And 36 and 5 is 41. So who's winning? The negative or the positive? Well, the positive's bigger, so I know that the positive is going to win. Here's my negative. There's my positive. My positive's going to win. And by how much? So I know 32 is going to be my denominator. "41 says, all right, 22, you're gone. But 22 is like, all right, but I'm taking 22 of your men with me. So we're going to subtract 20. That's going to give me 21. And then we're going to subtract 2 more. That's going to give me 19. 19 positives out of 32. Now we just need to double check and make sure that 19 and 32 don't have a common factor to simplify. Can I divide 32 by 19 and get a whole number? No. Then that means that this is my final answer for my question. So one thing about fractional strings is that it takes a little bit of work, but the skill is basic. Once you follow the steps, you're just doing the same thing over and over again. If you get confused, rewatch the video or contact me with questions. Good luck.